one of the videos, I think I remember when there's this video that, your second example, what's the second example called? Talk. Your second example, talking or something? Or... Anyway, I know when we were shown this for the first time, I mean, genuinely, and you've got a lot of cynical people in companies, obviously, that have been around a bit and they've seen most things. But when we saw what these guys in the lab had done, we just went, really? So, you know, it's as Pekka said, it's that one day a week when we allow them to do something crazy. Occasionally it works, maybe sometimes, you know, it doesn't. But, okay, so I think I've got somewhere in the region of 40 minutes now, and my intention was to talk more about enterprise asset management and the improvements that you can get in operational efficiency from it. Now, this is quite detailed. So I guess if I see you all going to sleep, I may just go a little bit faster. I might ask you questions, actually. I ask you questions if you're awake, yeah? And is that okay to go deep into what we have in this sort of area, yeah? I showed this morning, and the sort of areas of the application. So I'm going to go into the application now and just talk about certain features, certain functions, show you some screens in PowerPoint around what we have. And I hope that is okay, yeah? But I'm mostly going to focus in this area. So Pekka mentioned that we did a lot of work, and we built something to manage linear assets for our asset management solution. Because for us, a linear asset is different. If you have a power station, and typically you have the turbine hall and the turbine and generators and pumps and valves and these sort of things. These are typically traditional hierarchical assets, whereas a linear asset for us is a road, a bridge, a rail line, a transmission line, a length of pipe, yeah? And we built functionality specifically for this because we had customers that were working around the solution, the situation. And that was new functionality that we built in Apps 9. So just quickly, if you imagine that you have a road and you want to set this road up in IFS, and along this road, it has different speed limits. So this is in miles per hour, but it could be kilometers. Are you kilometers or miles here? Kilometers, of course. So, but it's the same sort of numbers, yeah? In fact, it probably is kilometers, actually, 110. And then you have a different surface for the road along its length, yeah? And then you have different numbers of lanes, goes from 1 lane to 2 lanes, back to 1 lane, this sort of thing. And what you want to do is you want to manage, this is quite a complex problem for an asset management system to manage. But we have built functionality that allows us to do all of this. It allows us to segment the linear. This may be one asset, one linear, but you want to identify where you do the work, where the problems are, when you did the work, deterioration rates to the asset. Is it this lane? Is it both lanes? Is it this type of material? So all of that is a very complex asset management challenge. And we have built functionality to manage all of that. And you just need to be confident that we've done that. One of the things that we did once we built that functionality was we revisited some work that we'd done a few years ago integrating IFS to geospatial, geophysical systems. So basically, these are third-party products, not IFS, third-party products that represent assets in typically a map, and they are called GIS products generally. And we always had an integration, but what we have done for Applications 9 is we have taken this integration as part of the visualization concept. We have taken this integration. We have won awards from Esri in the US. We have presented at Esri conferences in Europe, a couple of events. And we believe we have taken the integration to the next step, and we have a very, very, very configurable. This is important as well because it allows users to do all sorts of things in the tool. So fundamentally what you have is we've done the work with a company called Esri. Have you heard of Esri? You that are in the GIS world, yeah? Oh, perfect. We have done the work in such a way that you should be able to hook in other GIS products. There are other GIS products out there. There's from GE, Intergraph, so it should be able to. But the thing about Esri, if you may know, is that you can just go onto the Esri and there are websites and you can get libraries and libraries and libraries of add-on components that you can then embed, just widgets. And we're able to embed all of that capability directly in IFS and lift it off of IFS. So this is a summary of all of the main features. And one of the things that you notice here is that it is all configurable. In the context of what we are trying to address, you could, for example, manage the location of all of your engineers and just represent them directly on the map and use that to better optimize and schedule the workforce. You could create heat type maps of maybe the retail customers that buy the most from you at certain parts of the year. So this is not just about asset management. This capability that we've built here could be used in all contexts in IFS. The example I used earlier around incidents and accidents at an airport is absolutely somewhere where you can record where all of these incidents occur and then very easily visualize the areas of your estate, the areas of your organisation where you have the biggest problems that you need to look at. A major focus is, of course, on asset management. And in a particular example, I'm working with a utility company in the UK. We're using it for planning new construction. So we have, for example, developers, builders, construction companies come to our customer and say, look, we want to build 5, 6, 10 new houses here. How do we connect those up to the grid? And we've made sure that we've got all of the existing infrastructure from the water company, the power company, the telecom company, the fire company. So all of those different layers of information are all represented in the grid, and they assist with planning. So this is what it looks like. This is actually an old screenshot. So this is the map embedded in the application. This is a linear asset. You can select what layers that you want to see. So in the GIS world, you create different layers of data represented in the map. So if you wanted the complete network, maybe you want to show different sizes of pipes in the network, different sizes of cables. Maybe you want to show substations, connection points. All of that level of detail is all configured in the map. And then what you are able to do is in the map, you click on the object. So you're in this third-party tool. You click on the object and it pulls up an IFS form. And this is a form here showing object information. Now, the beauty of this is this is all configurable. If you don't want all of these tabs, you can hide the tabs. If you want a different tab, if you want the feature that Pekka mentioned around, you could create your own table. You can create your own table and embed it in here. You can create actions here yourself. Now, I understand this suggests that there is a lot of configuration, but it's really, the configuration is there because we understand you will grow, your business will change, and thus you need a solution that is able to be adjusted with you, if you like. We didn't want to give you something that maybe, you know, fault reporting was quite obvious. We could have left it at that, but, you know, let's give you other capabilities. So everything is you can change visibility, change the order, links, custom fields, all of the tabs can be changed, and the actions can be configured as well. So very quickly, just some information there about linears and the links off to GIS. If we then look at our traditional equipment component, there is no limit to the types of assets, the volume of assets, the depth of assets that can be added into this database. And generally, they are of different types. We've either got an asset that moves around, it's a pump, a motor, a valve, an electronic item, something we sell. If we're selling an item that we may want to service, then it's typically serialized. And we have other items, functionals, that are generally fixed. And you could obviously hold all of this supplementary data against these assets. It's not mandatory. If you don't want to manage warranty in the application, that's fine. If you're not looking to link off into the spare parts, into the inventory component, you don't have to. But you can grow your solution to this level. So what does it look like? This is a screen from Apps 9. We have here a structure. It happens to be a heating and ventilating system in a manufacturing plant. And generally, one of the big challenges that you have when you have a complex asset structure is navigating through the structure to the point, to the item that you want. Let's say it's a pump. You can navigate through a function, or you can navigate through a location structure, or you can navigate through a flow structure, or a positional structure, or a system structure. So we could navigate to the air conditioning through the air conditioning system. So we can represent, the point to understand here is we can represent the asset structure in many different system ways so that it is easier to come to the correct item. Yeah. Again, that's a relatively new feature. It's been around for us for about 2.5, 3 years. And again, quite unique. Oh, what's happened here?
Okay. It's a very good slide. So
yeah, it's a good. Oh, Citrix receiver.
Oh wow. Okay, moving on.
Okay.
All right.
Yeah, thank you. Sorry. We've not really touched too much on document management, but document management heavily utilised in asset management. So you've got an object, an item here, and here you can list all of the associated documents. These documents can be inherited. If it's a maintenance procedure, maybe it is inherited by the preventive maintenance check, and then maybe it is inherited by the work order. And maybe it ends up on the mobile tablet for the engineer. Yeah? It's a feature that's available everywhere. We have features like criticality. One of the areas that we have done quite a lot of work, and we are continuing to do work in, is risk-based maintenance, and the whole loop of failure mode and criticality effect analysis, so that we can analyse why failures occur and make improvements into the application. This is an area that we are working on ourselves. This is an area that we are linking into the Internet of Things. This is an area that we're working with partners. And that ability to predict when there is likely to be a failure is, going to really be, I think, the future. And not just predict, but I was talking to some guys in Japan from our partner NEC, the big Japanese electronics company, and they are doing work in this area around sort of neuro-learning type features, whereby their program will not only learn as these sensor values come in, but it will start to adjust its learning, if you like. Really advanced. I mean, it's far more advanced than I can understand, but that's where we're going to be going in terms of predicting maintenance. Pekka talked about some of the visualization capabilities we've got here. This is just really showing you cost and breakdowns on jobs. Just moving on quickly. Again, in the preventative planned world, we would generally suggest people use a standard template, a standard task. If you're trying to roll IFS out across multiple sites, multiple manufacturing sites, you may want to have a standard library of templates of tasks and not allow everybody to individually adjust those, so that you can compare performance, compare maintenance efficiency. So we start off with standard jobs, and standard jobs can have a whole list of different features assigned to them. They can list all of the material that's required to execute the task. This is a standard pump overhaul, for example. We've got all of the work instructions, we've got the resourcing requirements, maybe we have to procure some third-party stuff to allow us to do this. We've got all of that. All of that is optional. Permits, isolation capability, it's all optional. If we don't want to be so rigid in executing this work, we don't want to isolate the item, then we don't have to use this feature. Standard jobs are compiled as part of a job program against all of the assets, and then the criteria that generates them is defined uniquely. So it could be hours run, temperature, vibration, condition, or it could be as simple as we do this job every 6 months or every 12 months or whatever. So all of that capability is there. Jobs get created and then they get executed on what we call a work order. Now, this can be as simple or as complex as you want. We can set up an asset with probably 3, 4, 5 pieces of information. We can set up a standard job with probably 3, 4, 5 pieces of information, and we can get the whole thing running in a very simplistic way if we wish. Or we can utilise all of the other capabilities. What does a standard job look like? Let's just rattle through these. Again, you can see the document management attachment that we've used here. We've got integration here to HR. So what we're doing here is, this is a task that we're giving the maintenance engineer. And what he or she has to have is some level of competence and a certified license that is valid, that is relevant. So what you've got here is a task, and you can go away and check their HR record to make sure that they are competent and they have the sufficient licenses to do that. And you can use that information in scheduling, of course. Yeah? Whether that's dynamic or a little bit more manual. And I talk a little bit about scheduling as we go. So this is what I mentioned earlier about failure analysis. We have item classes. So this is types of assets. And we define those types of assets, and then we define the function of those assets, the failures that can occur against those assets, the symptoms of those failures, the causes, and then, more importantly, the job that needs to be done to repair or overhaul this item. So what we're doing here is we're trying to direct the maintenance staff to the correct repair, analyse the correct problem, and ensure that we have consistent data across the patch. So this again is an area that we've done a lot of work on. Just quickly rattle on. We talked about standard jobs. Standard jobs are added to planned maintenance actions. We've got here 2 tasks. They just happen to be calendar tasks, and we've got some values about when they're due to be done. The whole area of preventative maintenance is defined such that obviously, if we have a task that has a calendar and a condition check, we only do one. If we have a 1,000-hour check and a 5,000-hour check, and the 5,000-hour check includes the 1,000-hour check, then we only do one check. All of that optimization of task management has been done here. And we mentioned and talked about if we're registering meter points. So we could have here the vibration parameters, temperature, condition, hours run. All of those details can be automatically received maybe from the control system directly. They could be received from handhelds as the staff go around. Those measurements are recorded in the application, and then the job gets put out. Now, just a question. Does anybody here do dynamic scheduling? So this is guys and girls in vans going out to repair stuff, where it's important to know distance, how far you have to go to get to the thing. It's generally, there are things like a service level agreement. You have to be at the job within 2 hours. The job has to be fixed within 1 hour. So generally it's a field service thing. Does anybody do that? So I'll maybe rattle through these quickly, but we have this capability to manage these elements. If we're in a factory, if we're in a manufacturing factory and we're doing scheduling of labour for work management, some of these, this is not important. this is maybe not important. Some of this is important, but it's a different scheduling and resource optimization conundrum. Can I say conundrum? You happy with conundrum? Yeah. So we have a capability to manage all of this, and what you do is you throw all of those business rules at the computer, and the computer comes out with better schedules. So all of those rules are enforced. The skills that people have, their position, their physical location, the SLAs, their working shift patterns, licenses, and this is what you would typically get. So you're working in a geographical area, and what it does is it manages the best cost-effective way of scheduling workforce. And then on a real-time basis, this is the scheduling workbench, on a real-time basis, it is monitoring from their handhelds what's happening. And as Pekka mentioned earlier, you tend to manage only by exceptions, jobs that need intervention, that are going to be late. So let's move through this quickly, if it's not relevant. And then talk about, if we're in we've got a different scheduling challenge here, and this is more around scheduling asset management when we are in a factory environment, where we need to integrate the maintenance plan with the operational plan in conjunction with all of the other requirements of skills, resources, materials, those sort of things. So we have another scheduling challenge. So I think the important thing for you to consider is that we can manage both scheduling challenges. Dynamic scheduling, lots of people, short duration tasks, or smaller numbers of people, tasks that maybe span over a shift, over a day, just a matter of hours. And this scheduling capability can be done offline. It is generally done to make best use of these 4 dimensions. So it's about optimizing the PM program. It's about replanning. Because this maintenance planning board can be done offline, you can do the maintenance planning schedule maybe for a big shutdown that's occurring in 2, 3, 4 months' time. You can take all of the schedules out of the application, manage them, and when you think you've got the best schedule, put them back in. So that's major planning of a large overhaul. You can use both finite and infinite resources. So if you want to assume how could we better manage this plan if we had more resources, you can add more resources into the database. These could be subcontract services, external services, maybe we hire more staff. All of that level of detail to come in. It considers operational plans and clearly is about maximising the operational uptime. And as well, it can link off into inventory optimization. So it's a different client to address a different problem, because it's looking at this type of time frame. If you imagine the other scheduling challenge, dynamic scheduling, is something we're looking at it today to schedule for the next 30 minutes, the next hour. And we have 1,000 resources or 100 resources, and we're trying to manage this. This is a different type of schedule. So here we have all of the tasks, the work orders. We have work order structures. You can highlight critical work. You can highlight dependencies. You can have work orders in a tree. You can build the relationships between all of those work orders. And more importantly, you can schedule the work. This is the work here, and these are the operational activities. So what you can do is you can, dependent upon the work, some work can be executed with the equipment running. You know, that's generally how it is. But some work has to have the equipment in operation. And all of that information and knowledge and intelligence is understood by IFS and held in IFS. And this particular tool is about optimizing the maintenance when the equipment is available. Okay, so just a few more slides around mobile. Pekka talked a little bit about the mobile device. I'm just now going to focus on the work order management component that we have. It operates on a range of devices and has clearly got tight integration to camera, phones, barcoding, all of those sort of capabilities. So this is what it looks like. Currently, in mobile work order management, we only support Android and Windows 8. We used to have a Windows 6 version, but you know, as the Windows hardware and operating systems has moved on, I think you can't get Windows 6 devices anymore. You know, we've moved up to Windows 8. We are building an iOS version, but I think the view about iOS and work order management in a factory is it's probably not the device that people will use. So these are the two devices that we've got a solution for. And hopefully what you can see is that, you know, it's a very visual, simple to use, but prescriptive. You know, we tend not to allow, or we tend not to want, you know, engineers, technicians, people that are carrying out repairs in the factory, we tend not to want them to spend all day looking for stuff. So the functions lead them through the process. They get a job in the morning. What's the first thing they do? They look at the job. The next thing they do is they may start the job. Yeah. So it leads you through that capability. The important thing to bear in mind is this is offline now. This is an offline capability. It's not connected to the database. It synchronizes back when you want it to, but because this is you know, in most examples, we expect people to be using this offline. It obviously has its own database capabilities on the machine. So it allows work to be undertaken while you're offline, pictures, signatures if necessary. But it's fully integrated all into the back office. So, you know, here you can look at today's jobs, tomorrow's jobs, those sort of things. This is what jobs look like. You select the job, and you know, it leads you through the process. And as well, this is configurable as well. So, how are we doing for time? Okay, so Pekka talked about lobbies and visualization. So I'm not going to go into too much detail on that, but just to say that we have, you know, in the service and asset management world, you know, we have clearly specific lobbies that have been developed. In the application directly, these are visualization. This one is representing This is a work order, an individual work order. You've got budget information on the labour cost, the materials cost, different costs around expenses, tools and facilities. You've even got revenue that you can manage on here, and all of that can be represented here. And then we've got here a breakdown of the costs per year in maintaining a particular asset. So again, as part of our drive towards embedded visualization, all of these changes have been made. And that's me. So I've finished a little bit, because I went a little bit fast, but I think I've probably sort of brought us back on time, probably. Any questions at all? I mean, obviously we're here to talk over the break and what have you. Any questions? Was that, well, here's the question then. Was that what you wanted to?
Any questions? Thank you, Colin and Becca.
No.
Thank you, Colin and Becca, for very
Sorry, was that wasn't a question, no?
Thank you for the presentation. And
Pleasure.
now it's-